Hello, everyone, and welcome to my presentation. My name is Chakradhar Sunkesula, and I am engineering manager and specializing in cloud infrastructure and security. Today, I want to share insights about building a multi-layered security framework that not only addresses today's threats, but also scales for the challenges we face in 2025 and beyond. Why multi-layered security? Because the threat landscape is more dynamic than ever. Attackers are constantly probing networks, APIs, and user endpoints, looking for the weakest links. If you rely on only one or two security controls, sooner or later something will slip through. But by using a series of defenses that reinforce each other, you reduce the risk that a single breach can escalate. During this talk, we'll explore the core components of such a framework, ranging from network security to AI driven threat detection to zero trust and beyond. By the end, you will have a practical understanding of how each piece fits together to create a robust shield around your cloud infrastructure. Over the past few years, the cloud computing market has grown tremendously, increasing into the hundreds of billions of dollars in value and projected to keep expanding at over 20% annually. With so many organizations migrating critical applications to the cloud, it's clear that security must be the paramount. The main challenge is that this rapid growth has dramatically increased the attack surface. Each new app, each new data store, each new endpoint becomes a potential vulnerability. Some reports indicate that nearly 43% of businesses have experienced at least one significant cloud security incident in the past 1 year. The biggest culprits, misconfiguration, inadequate identity management, and lack of effective monitoring. In this environment, reactive security strategies like patching after the breach are simply not enough. We need to be proactive. Layered defenses capable of identifying, isolating, and neutralizing the threats before they cause any real damage. That's the focus of this framework. Systematically reducing the risk across every layer of your cloud environment. Let's break down how a multi-layered framework is typically structured. We look at several layers: network security, where we implement firewalls, intrusion, detection, prevention systems, and segment networks. Authentication and authorization, zero trust methods, least privilege, and strong identity verification. API security and monitoring, checking each request with intelligent validation systems. AI driven threat detection, machine learning models spotting anomalies in real time. Resilience and recovery, built in failovers and rapid incident response, and a thorough documentation. By interlocking these layers, we ensure no single point of failure. The impact can be profound. Studies how organizations adopting these strategies often see major reductions, sometimes up to 90% in successful breaches. They also report faster resolution times and improved compliance. Ultimately, robust security isn't just about avoiding the attacks. It's about fostering innovation by enabling the teams to focus on building great products without constantly being worried about threats. Look at network security. Traditionally, every company tries to protect a single perimeter, assuming that everything inside could be trusted. But that model fails in the cloud. Today, attacks might originate internally or come through compromised endpoints. That's why we are shifting to a zero trust model, where no user or a device is implicitly trusted. In a zero trust architecture, each request, whether it coming from inside your network or outside, must be continuously verified. We integrate AI driven traffic analysis to spot unusual behavior patterns. For instance, if a user activity suddenly spikes at 3 a.m. in the morning from the country where you have no operations, we flag it or block it automatically. Additionally, setting up a tripwires in the network layer is highly effective. These are specific threshold or conditions that trigger alarms. For example, if the data exfiltration exceeds a certain rate or a sensitive resource is accessed unexpectedly, it sets off an alarm. The swift response prevents attacker from moving freely once they are in. The next critical layer is authentication. Compromised credentials remain one of the top vectors for breaches. Therefore, We employ multi-factored authentication, short-lived tokens, and strong identity verification protocols. We also classify users and devices based on risk. A low-risk user operating from a known location might only need a single factor of authentication, but a privileged administrator signing in from a new or suspicious location might require multiple steps, such as one-time password or biometric verification. If we detect or suspect a compromised token, we have an automatic kill switches that revoke session tokens across the board. This prevents attackers from leveraging stolen credentials for extended periods. Ultimately, trying an authentication tightly to the contextual risks ensures that only legitimate users gain access and only to what they specifically need to do their job. Once the users are authenticated, the next step is to ensuring they are only having the correct level of access. We employ a least privilege principles, meaning no one gets more permissions than they absolutely require. This alone can drastically limit how far an attacker can move if an account is compromised. Dynamic access control is the next evolution, where the systems adjust the privileges in real time based upon the factors like unusual location or high volume of requests. If something seems off, we automatically lock down key resources or prompt for additional verifications. Continuous auditing is also essential. Logs are checked frequently, and any deviations from the normal usage patterns trigger reviews. This real time feedback loop helps maintain compliance, and it also gives us crucial insights into how to refine roles and permissions over time. In the cloud native architectures, APIs tie everything together. They are only the prime targets for the attackers. That's why our framework emphasizes rigorously on API security. We validate requests at multiple points, checking headers, payloads, security. We validate requests at multiple points, right? We also ensure that each microservice trusts only specific tokens or request patterns, reducing the risk of unauthorized calls. Machine learning plays a big role in spotting anomalies at the API layer. If an endpoint typically receives 100 requests per hour and suddenly spikes to 10,000, we want an automated mechanism to flag or block that. We also integrate threat intelligence feeds that list known malicious IPs or suspicious domains, automatically rejecting calls from bad actors. By refining API security, we tackle a huge surface area for attacks. This is essentially important when microservices scale, as you may end up with hundreds or even sometimes thousands of endpoints to protect. Even with robust authentication, authorization, and API checks, threats can still slip through. That's where advanced analytics come in. We ingest logs through from across the network, combine them with external threats, threat intelligence, and apply AI models to detect anomalies in real time. For example, if a zero-day vulnerability surfaces, a system may notice new exploit patterns like specific error codes or unusual memory usage across containers. Automated responses then isolate affected containers or force update to mitigate the vulnerability. If a breach does occur, comprehensive logging helps with faster containment and root cause analysis. We quickly see which user accounts were accessed, which endpoints were compromised, and which data was touched. This clarity is vital for both legal compliance and for improving our defenses to prevent a repeat incident. While detection and prevention are crucial, so is resilience. Our framework builds redundancy across regions and aiming for nearly 5 nines of availability. If one region is under heavy DDoS attack or experiencing a catastrophic failure, we can fail over automatically to another region. Resilience also extends to quick recovery. We define clear runbooks for incident response: who does what, when, and how. Using orchestration tools, we can revert to the known safe state within minutes, minimizing downtime and limiting any damage. Another aspect of resilience is adaptive security systems that learn from each new threat pattern and update their models, firewall rules, or access policies in near real time. Over time, this continuous learning cycle makes the entire architecture even more stronger. Let's talk about the bottom line. Data breaches can be exceedingly expensive. Some estimates put the average cost of breach in the millions of dollars, factoring in direct losses, legal fees, regulatory fines, and the brand damage. By implementing a thorough, layered security approach, organizations often see a dramatic reduction in their cost, sometimes up to 76% savings on incident response and faster mean time to recovery. Additionally, robust security often leads to lower cyber insurance premiums as insurers recognize the reduced risk. For companies that handle a lot of sensitive data, these savings can be substantial over time. Beyond finances, you're also safeguarding your reputation. Maintaining a customer trust is priceless, and a well publicized breach can erode that trust very quickly. To wrap up, we have seen how a multi layered cloud security framework can address the growing challenges in cloud environments. By combining zero trust principles, AI driven threat analysis, strong authentication, and continuous monitoring, we create a defense that's flexible, intelligent, and deeply resilient. Looking forward, we will see advances in areas like AI driven forensics, microsegmentation for containerized workloads, and adaptive identity management that evolves with user behavior. An attacker become more sophisticated, we must remain vigilant and proactive, continuously refining these layers to stay ahead. Thank you.